We're live. We're live. Okay, great. So, finishing off on where we were last week. We'll go through this example, like I said, and then what we'll do is I have about 7 or 8 questions that we'll start processing our way through. So in this question here, we're going to take in an integer from the user. I'm going to count from 1 up to whatever that integer is, summing the numbers as we go along. So if they enter in 10, we're going to add 1 plus 2 plus 3 plus 4 plus 5 plus 6 all the way up to 10. And we will output whatever the total is. If they enter in 20, well, then we update it. The whole point of our loop is that the action we're doing each time in the loop is a systematic process. And that means that we do the same action and we just repeat it over and over and over again until we get to the condition that's going to end our loop. So the way this is going to look is we're going to start off our keyboard input, not keyboard input, our import statement, because we need to have keyboard input. We have our class, our public static void main, we get our counter variable, we have our sum variable here, and we have n, which will be the value we will take in from the user. I've initialized my counter and my sum because they're not generated from user input, they're only going to be generated from calculations, so we need a starting value for those. Whereas the variable n, because that's what I'm going to use to store the user input, I don't necessarily need to set it to 0. You can absolutely do that. It doesn't make any effect on your program. But you can also not do it, because on the next page, once I have created my scanner, I'm going to prompt the user to enter the value, and I'm going to put it straight into n. So we can't get past line 15 without initializing variable n. So there's no way of getting to the point of the program that after line 15 where we're using the variable n without it being initialized. If the user is really unfriendly and enters in a negative number or enters in a character or enters in something that's not an integer number, it'll break the program, make the program work unexpectedly. But for first year, we can usually assume if we give the user a prompt of enter an integer greater than 0, we have a friendly user. They're going to do what we ask them. Every now and again, I'll ask you to write a program where you have to make sure that they only enter numbers between a specific value. And actually, what we can do, one of the programs I'm going to do is, hang on, while I remember it, let me quickly write it down. We're going to make sure that the loop keeps going around until they enter in a valid range. And what that will allow us to do is to say, for example, the days of the week question or the month of the year question, that they have to enter in between 1 and 7 or 1 and 12, that they enter in 13 or minus 200. That it just loops around again and goes, that's wrong, please enter in an appropriate input. And we can do that however many times it takes for it to sink in that the user has to enter in a valid input. So here we're going to prompt the user, and we're going to take the value in from the user. Our loop, which is the new part here, is our variable. We're going to run our counter as long as it has a value less than or equal to n. So remember, we're starting at 1, and we're counting up to and including whatever number the user enters in. So we'll count if they enter in 10. We will count it all the way up to and include 10. Inside the loop, this is the bit that never changes. This is the repetitive part. And this is why our programs are now much more useful now that we've incorporated loops. The process of summation is an incredibly simple calculation. Take one number, another number, add them together. Right? That's not a difficult part. Everybody in this room can do that. And after maybe the first 20 numbers or the first 200 numbers, you might get distracted or tired or not pay as much attention. Computers don't lose their attention. They don't get distracted. So we could put in a very large number here, and the summation calculation will keep working. Also, it does those calculations faster than we generated. So on line 20, if we're allowed into the loop, we're going to take the current value of sum and the current value of count and add them together and set that as the new value of sum. And then we're going to increase count by 1. So it starts off sum as a starting value of 0, count as a starting value of 1. Add them together, we get 1. That is now the new value of sum, and we increase count to 2. It'll go around again. We have the value of 1 and the value of 2. Add them together, we get 3. Set that as a new value, increase this to 3. Then we get 3 plus 3 gives us 6. Increases to 4. 6 plus 4 gives us 10. So you can see where this is building up from. And it's just adding the previous numbers together, updating the value of both the variable sum and of the variable count, and doing it over and over and over again. And as long as the value of count is less than or equal to n, that loop will go around and around and around. So if I set in 10 as my value, as my user input for the value of n, it'll say, well, look, here's how much we're going to print. If I sent in 10,000, it will do the same calculation. It'll just run for a little bit longer while it adds up more numbers. But the internal part remains the same. It's systematic processing. Okay, it's like an assembly line. If you've ever seen footage of an assembly line, I don't know if any of you work in a environment that has assembly lines, but if you see something where they have a chocolate factory where they're making chocolates, if you've ever taken the tour of the Butler's chocolate factory in Dublin, they can run this conveyor belt of hundreds or thousands of chocolates, and they all go through the same exact process. And that's what we want. We want essentially that type of conveyor belt. Know the number, do this action, do the exact same thing we've done for however many numbers beforehand and however many numbers yet to come, and repeat and repeat and repeat and repeat. It never really varies. The action, the evaluation is the same for every number or for every value we're looking at. And the only thing that's changing is we're slowly moving toward an endpoint. And when that loop is finished, so when count is greater than the value of n, so in our example, if the user enters in 10, when count gets to a value of 11, it's going to stop that loop. So we will not be allowed to run line 20 or 21 again. We'll jump down to line 24, where we're going to tell them the sum of 1, 2, whatever the number they entered in, is equal to, and we put in whatever the output of that is. Every part of that program, except for this slide here, is stuff we've done before. There's not really any new elements in it. This is the new thing, the new topic that we're looking at. While we're looking at that slide there, does anyone have any questions for me or any bits that you are unsure of or you'd like me to go over again? Can we do which? Absolutely, yeah. This will be the first one that I'm going to implement when I finish off the slides. Okay. But from a conceptual point of view, does anyone have any questions? So the question was, can we do this as an exercise? I'm absolutely going to do this as the first example. But if you have any questions on any of the commands or why we're writing in a certain way,
it's just going through once each time on command, is it, or when is it stop?
Sorry, say that again?
It just goes. It loops each time on command, is it? Or
not on command. It's, as soon as the loop starts, it'll just run automatically until we get to a point where this statement here is no longer true. Just like with our if statements, whatever goes inside the brackets has to be able to be evaluated to whether it's true or false. As long as it evaluates to true, so the number 1 is less than or equal to the number 10, well then everything's fine. We're allowed in, we can do the stuff inside the loop, and we come back around again. When it starts to evaluate to false, well then we're no longer allowed inside the loop, so we jump down to the bottom of the loop and continue on with the rest of the program. That make sense? Okay. Okay, so here again is another example. Enter the number of times to print out hello. So we're going to enter the value of 3, and then we'll print out hello, hello, hello. Okay, and the code for that looks a little bit like this. This is obviously not a full program, it's a segment of code. But we're going to say enter the number of times. We're going to take in our user input. We're going to have our I as our counter variable there, equal to 1, while I is less than or equal to count. We're going to print out hello. We're going to change I. If you ignore this line here, the printout line, and if you ignore the names of the variables, this loop here and this loop here are almost identical in structure. While number 1 is less than or equal to number 2, do something, and then increase the value of number 1, the left-hand side of this operation here. We do the same thing here. While number 1 is less than number 2, do something in here and increase the value of number 1. So a lot of the loops we're going to look at are that repetitive task where we have a number at the end on the right hand side, which is not going to alter, and we have a number on the left hand side, which is what's going to change. It's our progression statement. We're going to do something in the loop, and then at the very bottom we have the value that's going to change our left hand side variable, so that it's going to move toward the right hand side value. If this starts off at 3, and this starts off at 1, the plus action is going to move from 1 to 2 to 3. So slowly move it toward that ending point. Does that make sense? We could also rewrite that where we count down. The exact same loop, it functions the exact same way. We are still altering this. We've changed the variable names around a bit, but we still have a variable here called count, and we are moving it toward the variable or the value on the right-hand side. So the count minus will reduce this from whatever the user enters in, let's say 3 to 2 to 1. The action, the result of this loop, is identical to the previous one. The only difference is counting up or counting down. And depending on your problem, you may choose to do one rather than the other. But from a functionality point of view, it usually makes no difference whether you count from 0 up toward a larger number, or you count from a larger number down toward your lower number, 1 or 0, whichever you're reaching for. Okay. So this is a different type of loop, and actually this will be incorporated into the examples that I do. What loop we use for this? So one iteration of the loop, we're going to ask them, please enter a number. We're going to let them enter in a number, and we're going to print out the square. We're going to ask them to enter in a number, let them take it, or send in the number, and we're going to print out the square. We're going to ask them to enter in a number. We'll take that number. We're going to print out the square. We're going to ask them to enter in a number, and they've entered a negative number. And that's going to break the loop. It's going to quit out of that loop. Okay, so for this example, the two previous ones we had, this one here and this one here, are counting loops. Oh, excuse me. So we have a value that is changing, is moving along a number line toward an endpoint. And we know, we can calculate, oh, well, it'll be whatever value the user enters in, it'll be that number of iterations. If they enter in 10, this loop will run 10 times. If they enter in 10,000, this loop will run 10,000 times. We can calculate that because we know the starting point, we know the ending point, whatever value the user enters in, and we know the increment. We're going to move by 1 each time. So that's a mathematical calculation that we can do, and it's reasonably easy for us to do. This one, however, we don't know how many times that's going to run. This is very close to your guessing game question on your worksheet. This could run, in this example here, it ran for 3 times. We could run it for 500 times. We could run it once. We don't know. It will keep running until the user enters in a negative number. So what that's going to look like is this. Our loop will prompt the user, read in the number. It'll check to see does it exit. If it does exit, well then it quits out of the loop. If it doesn't exit, it'll display the square and go back around again to prompt the user for another number, take in another number, check if that number means we have to exit. If it doesn't, print out display, go around again. It'll keep going around until we meet the criteria for our exit test. Okay? So they're the first 3 examples I'm going to go through. I'm going to type out the code for the, the first 4 examples. I'll type out the code for this one here. We're taking in our number and printing out the sum of the values from number 1 up to that number. We'll then do a counting up loop, a counting down loop, and then we'll do that last one, keep entering in values until we hit a negative number. Have I got that there? Da, da, da. Yes. Okay. So I have a couple of examples written on the screen to remind you what to do. So let's have a look at some examples here. So if I go to my code here, I've created my scanner. I'm also going to create my input variable, which will be what the user can enter in. I'm going to set it to 0. I'm going to create my counter variable. And I'm going to create my sum variable. And if I have a look back at my slides, I can see that I initially set my counter variable to 1. So I'm going to change this to be 1 here as well. So there are just my variable setups. I have my system or my scanner, which will allow me to take user input. I have my variable called input, which is where I'm going to store whatever user input I've taken in from the user. I have my counter, which we're going to be counting at 1. And I have my summation value, which is going to hold the running total of the addition of all of our numbers. The next thing I want to do is I want to prompt the user. I'm going to take in a value, so input is equal to kv.next int. Okay, so they've entered in a value there. At this point, what I'm going to do is I'm going to start my loop. So my loop is going to look like this. We're going to use the keyword while. My counter is less than or equal to my input. Inside, I'm going to have the same calculation I had previously. So sum is equal to sum plus my counter. And then when I've done that calculation, I'm going to say counter plus plus. Just incremented by 1. This could also be written as counter is equal to counter, there we are, plus 1. Okay? They're equivalent to each other. Again, as I've mentioned last week, this is such a common increment that you're just going to change your counting value by 1, whether it's up or down, that we have this shortcut here. If I wanted to change my value by 2, well, then I'd need something like that. There isn't a plus, 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 plus. It's you just say plus whatever the value is. And at the very end, then what I'm going to do is I'm going to tell them what the summation is. So then if they finish the loop, and this loop will only finish when counter is larger than input. It'll go from 1 all the way up to and including whatever value the user enters in. And once we go 1 beyond that, it'll say, okay, that's it. We're finishing the loop because the left-hand side is no longer smaller than or equal to the right-hand side. The left-hand side is now larger. And that means that this statement here is no longer true, which means we're not allowed in to run line 14 or 15. So here we're going to say the sum of 1, 2. Now, I'm going to try to spread this out in multiple lines. Input. Equals plus sum. Okay. So you can do this. See the way I've split my printout onto multiple lines? It doesn't make sense. I obviously have my font up as large as possible, as you can see it in the back of the room. If I wasn't doing that, I'd have it probably about that size for me, which it seems ridiculous to spread this over 3 different lines. But you can spread it over that for readability by making sure that the end of your line ends in a connector, ends in an addition symbol, so it knows, oh, there's more to come on the next line. So that's our first question there. So let's save that. Let's go to our command prompt. Let's go to our desktop. Oh, I've adjusted the font. Is that readable from the back of the room? Yeah. Yeah? God bless your eyesight. I was going to increase it by just up to 28, just a little bit easier there. Right, so here we're going to say Java C loops. Any moment. There we go. Right, and then Java loops. To enter a number, let's go with the examples I had in the slides. So if I enter in 10, the sum of 1 to 10 is 55. Great. Let's run it again. We don't need to rebuild it because we're not editing the code. We only need to run it again. The number 20, then we should get 210. Super. Let's enter in a bigger number. Let's enter in 500. And 1 to 500, the summation of that is 125,250. So you can see that we're going to very quickly run out of space. If I do 1,000, 500,000. Okay, let's do an even bigger number. Let's do 15,000. Okay, we're getting to the limit of what we can do now. Let's do 20,000. Okay. Let's do 100,000 there. Is that 100,000? Okay. So you can see that we're still working our way through this. If I ran that again, 0 there. Right. Okay. Now, let me increase the font so everybody can see that. So our second last output here is this huge number here. That's the summation of all of the values between 1 and how many? And 1 million. This is the summation of all the values between 1 and 10 million. But I have a negative number. Can anyone guess at why I have a negative number?
Got all the digits.
Yeah, and you're right, but why are we ending up with a negative number then?
Is that the difference you're all about?
Kind of. Have you done 1s and 2s complement with Paddy yet? Computer hardware? We have that number wheel which is going to go 0, 1, 2, 3, 4, 5, 6, 7, minus 7, minus 6, minus. Okay, right. You get to that. So what's happening here is we have an overflow issue. It's an error essentially, but it doesn't crash our program. I've mentioned that we have a finite amount of numbers in our integer range. It goes from negative 2.4 billion to positive 2.4 billion. And what happens is when you get to the maximum on either range, and you either deduct 1 or you add 1, which I realize for you guys is you deduct 1 or you add 1. What it does is rather than crashing the program, it loops right around to the far end and continues counting. Now, for us, that's kind of ridiculous because it doesn't make sense here. That's 2.04 billion there. But what it allows the program to do is essentially count forever. And as soon as it gets up to the maximum range of the number, it drops down to the lowest possible integer number, which is negative 2.4 billion, and continues counting. If all you needed your program to do was count and essentially run forever, the way numbers are set up, the way all numerical values are set up, is they're circular numbers. Once you hit the end of one range, you connect immediately to the far end, and so you continue going around. It's called an overflow. It happens in programming. We're not going to deal with it a huge amount, but it's good to be aware that that's what can happen. If you take 2.4 billion and you go plus 1, it doesn't crash the program. It figures a way of, well, how the hell do we get around this? Oh, I know. Drop it down to negative 2.4 billion and start working my way back up again. Okay, that was our first example. Screen there. There's the code. So the new bits here is really just this. That's all the new stuff that we have in. We have our while keyword. We have our Boolean guard. That's the bit inside the round brackets here, which is going to do some sort of comparison operation. It's going to check a number on the left-hand side, counter, against a number on the right-hand side, input. And as long as you can say, well, this is true, you're allowed inside to run lines 14 and 15. As soon as you say, well, this is not true anymore, you're no longer allowed inside here, and you have to go to the rest of the program, which for us is just write IT. Does that make sense? Any questions on that one? Okay, let's do a couple more. And I'm actually going to go backwards first of all, and just do a really basic counting loop, and then we're going to slowly build up from that. If you have questions as I'm doing this, please shout them out, because if you're unsure of an element, statistically there's at least one other person in this room who's also unsure, so it benefits everybody. Okay, I'm going to comment that out, and comment that out, and comment that out. We're not going to need that. I'm not going to need that. Okay, so the first loop I'm going to do is just going to count from counter to this. We'll just do a counting loop that's going to go from our lower value, which is going to be counter, to our higher value, which is going to be input. I've commented out our user input. I don't need that yet. And in here, I'm just going to say system dot out dot print ln, and we'll print out whatever the value of counter is. Still can't spell. Right, and then we go counter plus plus. So this is the most basic type of loop that we deal with. It counts from one number to another number in increments of 1, and all it does is just print out the current value of that variable. There's no evaluation, there's no questions been asked, there's no processing of values to be done. It's just, let's print out that number and move on. So if I take this, I'm going to go here, I'm going to go Java C loops 2. Print out loops 2. It's just going to print out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it does it on a new line because I've used print ln. If I got rid of that ln, compiled again, and ran again, it prints them all out on one line. But if I'm going to do that, that looks a bit messy. That doesn't look like 10 different numbers. That looks like 12 billion. Okay, so we can go in here and we can say, well, also add into that comma and a space. So now we can run it again. And now it looks a lot neater. Okay, so all I've done is I've said, rather than having all the numbers squashed up together, and they all are individual outputs. So it prints 1 first, then 2, then 3, then 4, then 5, and so on. Here I'm just putting a comma and a space so we can separate them out and see it a little more clearly. And I did that just by adding in. Every time you print out the current value, also print out a comma and a space. Now it leaves us with a comma at the end of the line, but for us that's trivial stuff. We don't need to worry about that. There are ways we can deal with that. You could write an if statement to see, is this the last thing on the loop? And if it is, well then you don't print out the comma. But if it isn't, you do. But that's making things more complicated than you need. That's probably going to be the question I'm going to say to you next. Okay, so that's a counting up loop. And we use counting up because we start with counter, which starts initially at 1. And we're working up to a larger number, to number 10. And we use plus plus to move ourselves up. Save that one there. Save as. So the next logical conclusion is let's do a counting down or a decrementing loop. Loops 3, loops 3, and we're just going to reverse the values. We will say counter is equal to 10 and input's equal to 1. We actually don't need this here either. And we're going to rewrite this. We're going to say, well, counter is greater than or equal to input. We're going to print out the value of counter, and because we're decrementing, we should have this as minus minus. So it starts at the big number and it's working its way down to the smaller number. So if I go back in here with Java C loops 3, and then Java loops 3. It's basically the exact same loop. The only difference is rather than starting at a low number and working my way up, I'm doing the opposite. I'm starting at the high number and working my way down. If I did that, we'd have a very different output. So this is a loop where I'm starting at the large number and I'm working my way down to the lower number, but I wasn't paying attention. Because I wasn't paying attention, I left this as plus plus. So what's going to happen is 10 is definitely a number that's bigger than 1. So we'll be allowed into the loop. But if I go to plus plus, I'm not reducing that down towards the number 1. I'm increasing it from 10 to 11. So to keep counting up. And so what happens is if I run this code now, it just keeps going. And going and going and going. And that can be hard in your eyes. But what's happening is I'm moving away from my end point. And if I do that, what this would be, if I let it run, is effectively an infinite loop. It will keep running. If it wasn't so tough in your eyes to watch that type of very fast output, and we had enough time to run it, we would see that we would go all the way up to the limit of an integer, and then we'd loop down to the negative side. It would keep counting, and it would go on and on and on. And what would eventually happen is I'd probably shut down the machine more than anything else. That's what would end up stopping it, rather than it runs out of memory, rather than it runs out of space to run this program. It's just I get bored of it and I shut down the machine. So we need to make sure that if we have a loop that's counting down, that we are actually counting down. Otherwise, our loop won't work.
How did you stop it that time?
I press Control and C. That's actually a really good question. Now that we're dealing with loops, and more than likely, all of you will make at least one infinite loop, where just something like that happens, it just will not stop. Control and C on a Windows machine. Is anyone using a Mac in here? Okay. I think it's going to be Command and C or Command and Q. I cannot remember. It's not going to make any difference on your terminal whether it's either Command and C or Command and Q. If it's not one, it's the other. The other possibility might be Command and X. It's been 9 years since I've used a Mac, so I can't remember what the actual command is. But that's how you quit it. Or you could just go up and click the red dot and it'll shut down the window for you. But yeah. Everyone's going to come across an infinite loop at some point. Okay, so I've done a counting up and a counting down. Let's do a slightly more complicated one. Let's do a loop that counts from 1 up to, and let's change it now. Let's let the user define how big we're going to go for. So save this as loop 4. But rather than printing out every number, let's only print out the even numbers. So now we've added an element of complexity. So we can add in, this is loops 4. We can take back our scanner, because we're going to have user input. We can allow, we actually don't need this for some. We can prompt the user for a number. Great. We can start our counter at 1. Input will set to 0. This is just going to be set here. Our counter is less than or equal to that. But rather than print out every number, we're not just going to have a list of actions. We run through all those actions every time. We are now going to add in an element of evaluation. I'm going to evaluate every number, but depending on how that number is evaluated, true or false, I will do an extra action for some of the numbers. So what I'm going to do is I'm going to write my if statement. So I'm going to say if counter, there we are, modulus 2 is equal to 0. No, I want to do even. I want to do odd numbers, so not equal to 0. If I divide the number by 2 and I don't get 0 as a leftover, that means it's an odd number. Then I am going to print out that number. Print out that number, and regardless of whether I print the number or I don't print the number, I want to make sure that I increment my number up by 1. And this is a really common mistake. What often happens to first-year students is we learn how to do loops where we do all of the commands, like the previous couple of examples we've done. You get into the loop, you do every single thing in there every time. And then we make our loops a little more sophisticated, a little more complicated. And so we can say, well, let's do an evaluation here. And depending on this evaluation, we'll run line 14. But we only run line 14 sometimes. And then they leave the counter ++ command inside this loop. So think about the first number we're going to check is 1. 1 is not, 1 would be a odd number. So it would print out 1 and a comma. And then because this counter ++ would be inside the loop here, or inside the if statement, it would increment it to 2. 2 is not an odd number. And it would never change that value again because it would come back around again. 2 is still not an odd number. 2 is still not an odd number. And that would run and run and run and run. So let me show you what it should look like. And then let's break it. And so you can see how frustrating that can be. Okay, so here we're going to have Java C loops 4. And then here we're going to have Java loops 4. We're going to prompt the user, please enter a number. So let's enter in 25. And it prints out all of the numbers, but just the odd numbers. It doesn't print out any even number, hopefully. No, it doesn't. Okay. Now, that's one way of doing it. I have also seen some students get rid of that, get rid of that. And just do that, which technically is correct. You don't need an if statement then, but you're only going to count in twos. So you're going to go 1, 3, 5, 7, and so on. That's valid. Let's revert it back to the way it was. Let's put this loop inside here. Okay, so this is the error that I'm saying that sometimes students do. They have a loop, and inside the loop they have some sort of an if statement to ask a question, but they put all of the code, whether it should belong there or not, inside that if statement. So when this runs, the first time it runs, it's going to evaluate 1 as an odd number and print out 1, and then it won't print out anything else, ever. So again, it doesn't matter what number, 45. Right, and that's just going to sit there, and sit there, and sit there. The program's still running. I can't really type anything. Nope. I can't do that. Oh, I killed the command prompt. Right, okay. So I used up enough memory there to kill that. So we shouldn't be doing that. Think about, the key with this is thinking about logically what do we want to have happen. For every number between 1 and whatever the user enters in, I want to check, is that number an odd number? If it is, I want to print it out. If it's not, I'm not going to print it out. But for every number, when I finish doing my check, is it odd or is it even, I'm going to move on to the next number. If this line here was inside my if statement, it wouldn't do that check for every number. It would only do it for the numbers that were valid. And as soon as I increase it from an odd number, it becomes an even number. And then it won't work for me. Okay? Right, I'm going to leave that on the screen. Actually, I'll do one better than that. I'll put all the stuff in the OneDrive. But I want you to slightly amend this code. I want you, rather than counting from 1 up to whatever the user enters in and checking to see if they're all odd numbers and only printing them out, I want you to do the opposite. I want you to take a value in from the user and count down from that to 1, but only print out the even numbers. So it's a very slight amendment from that. What I'm going to do, I'm going to put the 4 questions we've done up on the OneDrive, so you can get access to them there. I'll leave this up on the screen for a couple of minutes, just so you can have a look at it. It is 7:45, so between attempting this question and grabbing yourself a cup of coffee, we'll be back here at 5 past, where we'll go through a solution for this.